Put your hand on your chest. Feel that small rise. It feels like nothing. It is actually the loudest evidence in the universe that something is very, very wrong with the physics textbook. Because for that chest to rise, you need carbon, water, stars, planets, and time, all sitting inside one narrow lane. And that lane is controlled by a single invisible dial hidden inside empty space. Turn the dial slightly one way, and space stretches apart so fast that galaxies never form. No Milky Way, no sun, no chest rising under your hand. Turn it slightly the other way and the whole universe slams shut before a single atom gets built. So where is the dial actually set? Not on big, not on small. It sits near 10 to the minus 122. A decimal point, then 121 zeros, then a number. Physicists have a name for that dial. They call it the cosmological constant. They also call it the most embarrassing number in all of physics, because nobody can explain why it didn't just kill us instantly. Here's the machine under the hood. When you look up at the night sky, you are mostly looking at nothing. Freezing, empty vacuum. Except empty space isn't empty. It is quietly boiling with energy, a tension sewn into the fabric of reality itself. That energy wants to push the universe apart. Gravity, made by every star and galaxy, wants to pull it all back together. Picture a trampoline sagging under a bowling ball. That's gravity. Now picture the trampoline fabric stretching outward at the same time. That's the energy of empty space. For the universe to work, those two opposite forces have to match. Not roughly. They have to match to 1 part in 10 to the 120. Let me turn that number into something you can see. Take 1 grain of sand, paint it red. Now bury it in a pile of sand the size of the entire observable universe, 93 billion light-years wide. You're blindfolded. You reach in once and pull out 1 grain. If it's the wrong grain, reality never happens. The universe reached into that pile and pulled out the red grain on the first try. Randomness apparently took the engineering exam and aced it without studying. And this isn't a hunch. In 1987, physicist Steven Weinberg worked out the ceiling, exactly how hard empty space could shove before galaxies could no longer hold together. There was a hard limit, and the real value sits suspiciously below it. Then in 1998, 2 independent teams measuring exploding stars expected to watch the universe slowing down. Instead, they found it speeding up. The dial wasn't decorative, it was wired straight to the engine. That discovery won a Nobel Prize. An accident, apparently, with a calendar. Now here's where the shrug starts sweating, because the dial is not alone. Look at the carbon in the hand you're holding up. Every atom of it was cooked inside a dying star. But getting carbon out of a star should be almost impossible. It needs 3 helium nuclei to slam together at the same instant, and the halfway step, beryllium, falls apart in 1/10 of a trillionth of a second. Picture building a 3-block tower where block 2 dissolves into sand before block 3 arrives. That tower should never finish, and yet the universe is drowning in carbon. In 1953, an astrophysicist named Fred Hoyle stared at the failed math and said something almost illegal in science. I exist. Carbon exists. So there must be a hidden shortcut nobody has measured yet. He wrote down the exact energy that shortcut would need. A precise resonance inside the carbon nucleus at 7.65 million electron volts, and told a lab full of physicists to go look. They thought he was hallucinating. They looked anyway, and they found it. Almost exactly where he said it would be. It's called the Hoyle state. Here's the part that should bother you more, not less. That single resonance had to balance 2 separate forces at once. The strong nuclear glue holding the nucleus together, and the electric push shoving the protons apart. Shift the strong force by about 1%, and the whole thing collapses. 1% stronger, stars burn through their fuel in a few million years. 1% weaker, nothing heavier than hydrogen ever forms. It's one thing to win the cosmic lottery once. It's another to win it 50 times in a row. Every single time the laws of physics get drafted. To feel how humiliating this is, watch what happens when humans try to touch precision like this. When NASA, Caltech, and MIT built LIGO, an instrument to catch ripples in space-time, they had to detect a movement 10,000 times smaller than a single proton. It took 40 years, billions of dollars, and thousands of scientists. They hung mirrors on glass threads. They fought the vibration of trucks driving miles away. When it finally worked in 2015, they handed out Nobel Prizes. Meanwhile, a single hydrogen atom balances the nuclear forces, electromagnetism, and gravity, endlessly, effortlessly, since the beginning of time. We supercool magnets at CERN to colder than deep space, just to keep protons walking in a straight line. Projects like ITER in France have spent decades and tens of billions chasing the simplest fusion reaction there is, and still can't hold it steady. A dying star runs a far more delicate reaction correctly on the first attempt, then keeps running it for a billion years, with no control room and no do-overs. If we could actually turn the cosmological dial the way the universe does, energy would become a rounding error. Propulsion wouldn't mean burning fuel. It would mean shaping space itself. So we build machines to measure it. ESA launched Euclid in 2023 to map the dark universe, and after all of it, we still can't turn the dial. We can measure the footprint, we can map the crime scene, we just can't make the arrest. Some physicists reach for a rescue. Maybe there are countless universes, each with random dials, and we simply live in the rare one that works. Maybe. But notice what just happened. To avoid one finely set universe, we now need a giant factory that mass produces universes, plus rules for handing out the settings. Randomness apparently needed a factory, and the factory needs its own instructions. So what do we actually do with a universe this suspiciously tuned for us? The physics community has an official answer. It's called the anthropic principle, named by Brandon Carter in 1973. Stripped down, it says, the universe has to look this way because if the dials were even slightly different, we wouldn't be here to notice. So don't be surprised. Our existence demands the perfection. That is not an answer. That is a surrender. It's like standing in front of 1,000 expert marksmen. The order to fire is given. 1,000 rifles go off. The smoke clears, and you're untouched. Every bullet missed. And you say, well, of course they missed. If they hadn't, I wouldn't be alive to wonder about it. Technically true. Also not something you'd frame on the wall. The anthropic principle explains why observers find themselves in an observer-friendly universe. Fine. But a fish can explain why it lives in water. It still hasn't explained the ocean. It doesn't loosen the safe. It doesn't make the dial less sharp. It doesn't explain why the winning number was sitting inside the box at all. Because here's what's left standing when the excuses run out. The value held still for 13.8 billion years. It sat close to zero, but not exactly zero. Small enough to build a universe, precise enough to build you. A pencil balanced on its tip is impressive for 5 seconds. This one has been balancing since before the first star. So maybe it really is blind luck, one lucky grain of sand in an infinite pile. Or maybe it's worth noticing how quickly we reach for "we got lucky" the moment the numbers get too precise to be comfortable. Every parameter checked twice, every dial resting on a knife's edge. A universe that looks calibrated, down to the last decimal place. So here's the only question that survives the night. Who calibrated this if no one calibrated it?